positive note. Prost. So, tonight, I hear myself from there. Let me walk a little bit to that direction. So, tonight, I'm really happy to see you at our small vector space meetup, which is about the retrieval in the age of agents. And I am Evgenia, or you can call me Jenny. It's either there or there, I forgot. And I am a senior developer relations of Qdrant, the company which runs this event today. Let me start with a little bit of the overview. What are we going to do tonight? Obviously, we're not on schedule, but come on, who have seen any meetup on schedule? We will have a little bit of the introduction, and then we will have a slight keynote, which will give you maybe hope or maybe a sad reality of the future of search, but I think it's more of the hope today. Then we will have a panel, so you will watch us for 1 hour, yap together with the amazing companies which participate in the building of the retrieval of agents era. And this will be companies which you probably know. So besides the Qdrant, we also will have today a cognee, we will have NA10, we will have DeepSet, and we will have LlamaIndex joining this panel tonight. But this panel is generally only for discussing a little bit of the questions that you submitted for the Luma, and then giving you more information so you can discuss it through networking time. So the main panel is actually you. It's more important that you're going to walk away with sharing a lot of information about what's actually happening. Are you moving in production with RAG or agents? And then, of course, we will sooner or later wrap it up. Tonight is filmed. Thank you very much for our crew. So in case you zone out on the panel, you will be able to watch it on our YouTube later. A short introduction to what is Qdrant, because I've heard that somebody here doesn't know. You probably came from different Luma calendars, different communities. So a quick check. Who of you knows Qdrant? Can you raise the hand? Oh, it's a fair share. Okay, I don't count Qdrant employees. I hope they also know what is that. So usually people, when they think of Qdrant and others in the field, they think of the term vector database, which got pretty popular when the RAG got pretty popular. When we understood that LLMs are good enough, but they still hallucinate and they need a little bit of information or context which will help them to deliver the right output in your pipelines. We have a kind of hot take against the term vector database. Maybe not that hot, but I hope more hot takes will come later. That we are not a database, we're a vector search engine, because database is for storing data and vectors are not data, and there is no universal storage. I will keep it floating a little bit. You can come in the networking time and ask more details about this. So we have to talk about something more than how Deutsche Bahn doesn't work and Berghain doesn't let people in. So we built a search engine, not a database, to search vectors at scale, because you need to do a specific retrieval structure to allow it to scale dedicatedly. And moreover, we build on the idea that the search is a primitive. So everybody needs a specific configuration of searcher and retrieval and how to get information into their pipelines. And our goal is just to provide you a proper tooling out of which you can combine whatever you need. When you need a lexical search on the keywords, when you need a dense search and semantical search on vectors, when you need something more under filterable conditions, when you need something more exquisite and multi-vector, or you need to control the relevance score. Our goal is to deliver the proper tooling, and then it's your choice how to combine it. So there are basically 3 layers of control, kind of 3C rule, which allow you to use our engine. That will be the ability to compose out of the components what you want, control how it scores, your search relevance, and then configure how you want it and deploy where you want it, from edge devices on the camera to the clouds. Every workload, usually from RAG to product search to e-commerce to audio search that you build on the workshop, all of them pipelines need different configurations based on what you're caring more about, accuracy, cost, latency, or whatever. And as I said once again, you can compose and configure how you like. For example, in our production, we have certain companies which compose the way their workloads based on their needs, starting from HubSpot and Roche, ending up with Canva and Bosch, and they are rhyming, and I didn't plan that. So, but I don't think it's interesting enough that I'm talking about some companies when you're interested in your own future, and your own future depends on if we have any future, right? Because every other minute there is like, RAG is dead, is vector search going to survive, and all of that. So we thought that it would be nice if we will give you a short sneak peek in what we are thinking, what is our path of the vector search engine in this retrieval era, in this era of age of agents. And here our CTO, who is the one who usually decides what to build and how to build it, will give you a small keynote on how he approaches it now in the current days. So somewhere here should be my CTO, who will introduce you to his own opinion if there any future for vector search from now on.
Test. Yeah, as you can see from the style of my slides, I did it myself. Is it good? No? I mean, the microphone works.
You're not asking about the slides?
Yes, slides are terrific, of course. My kind of keynotes is named Vector Search at the Age of LLMs. It's not called, agentic search. It's not called, RAG retrieval or anything like this, because vector search is more fundamental than just agentic stuff. At the same time, agents are the biggest consumer of vector search at the moment. That's why we have to pay attention to them. So as you know, we have the second event running on the same day in San Francisco, which is much bigger and I guess more interesting. But you're lucky you have the next best thing. It's me. Yeah, I work at the search for more than a decade already, and I have a couple of opinions there. Yeah, so you can trust me, of course. So I want to start my keynotes with something I call a question asking guide. You know how you talk with Claude Code and it says, hey, you ask a great question? So this is opposite. It's more like a Stack Overflow style question asking, right? Because it starts with the wrong questions you can ask here. So of course, if this event about networking, you need to know how to ask proper questions, first of all. And the first wrong question is grep all we need for agentic retrieval? Why it's wrong question? It's very easy to prove that it's actually quite trivial to build something which is better than grep. Not comparable to grep, it's just strictly better, because grep doesn't do any ranking, and we can just slap ranking on top of grep and it will be better. What's the most proper question you might ask is, do I actually need indexing, right? So why people start to, switch to agentic retrieval in terms of using that just primitive tools is because they don't care about indexing, right? grep just works. Why spend time on indexing? An even better question you might ask is what part of my process, my pipeline, is the most slowest, the most expensive, which might benefit from having index, right? If it's not our text search, then what else, right? Of course, I'm pretty sure you're all not happy about cloud bills you have and overall cost of the agentic stuff. So what's a pain point here? And I'm not pointing fingers, but if you run something like an average scale language model, for each token it generates, this model does vector retrieval, full scan vector retrieval, like a full brute force search, about 100 times. Well, for some models it's smaller, for some models it's better, but vector search exists. It just exists in a different, plane of reality compared to what you have access to. So think about it. The second wrong question is, what you can ask is, should I put my vectors into relational database? Something like Postgres, for example. This is a very common question because, why should you, keep data splitted between different locations? Why would you need another solution for this, right? If you already have Postgres, right? So it's a natural question to ask, but in my opinion, it's a wrong question because it does not address the actual problem you want to solve. So the better question, I think, is what kind of guarantees you actually care about when you do vector search or where you store vectors. Do you care about transactional consistency? Do you care about like ACID style guarantees from the database? Or you more care about scalability? Or you more care about something like fault tolerance, right? This is a better question because it addresses the problem you're trying to solve. You're not trying to address the instrument right away, but you give person who you are trying to ask more context about your case, your solution you're looking for, and it's just much more pleasant to answer questions formulated like this compared to one before. And the most, correct, in my opinion, the form of this question is what actual trade-offs you can make to get a better performance, right? Because if you can avoid transactions, if you don't need transactions, then it's much easier to build something which will work faster, cheaper, and more scalable than something which requires transaction. The same goes for multiple other properties, not only transactions, right? If you can tolerate eventual updates, eventual consistency, that makes performance go much better and solution much more flexible, right? So if we understand your requirements better, we can build a better product for you. That's how it works. And finally, once we sorted all the questions and how to ask them, we can take a look a bit at the Qdrant roadmap, which we are building in 2026. And overall, this whole roadmap, I'm not going to talk about features, right? I'm not talking about fusion. I'm not talking about multi-vectors because it's some kind of features which are nice to have, but they do not differentiate Qdrant from everybody else, right? Everybody can build, RRF, or everybody can build, what else there are, like full text, right? Or regular expression filter. Like that's not interesting. What's interesting is different ways how to architecture the whole engine from the very ground up. And in the beginning of the year, we released our first attempt to, make our infrastructure more flexible. It's called Qdrant Edge. I think I have another slide about it. It is much more nicer because I used ChatGPT to generate those images. Yeah, you should try. It's really good. So the idea behind Qdrant Edge is that we have the same storage, the same storage layers, the same file format, index format as a main Qdrant core, but we kind of bypass the cluster infrastructure, I would say, right? So the consensus part, the distributed deployment part, the API part is all lives in the cloud only, and the edge part have direct access to the storage via Python API, Rust API, whatever other language you might want. And it gives us the flexibility of having search running not only in cloud, but also on the local device. So how many of you guys have been on the Berlin Buzzword, by the way? A few people, right? Have you seen our demo? Yeah, so not many people, but the idea is that you can take something as small as Raspberry Pi or Arduino Uno and install Qdrant on it, and it will run search locally without any access to cloud. And the fact that we use the same storage allows us to synchronize data from the cloud to local without changing any format, without recreating index. There are, of course, some limitations so far, right? So right now you can only download the whole snapshot, which defines the cold start problem a little bit, but what we can do next is actually extend this idea of having the local inference to not only use snapshots to take data from the server, but actually access storage directly through something we call the universal I/O, right? So this part I need, I guess, to explain a bit better because it kind of give you an understanding why Qdrant is in a unique position to build something you can probably heard of by the term of storage and compute separation, right? So usually what you mean by it is that like some service have two stages, right? The first stage, you upload your data. There is like ingestion service, which creates indexes for you. Then those indexes are placed into something like object storage S3. And then another service spawns on demand and goes to this object storage directly to do a search, right? So this is a basic concept of storage and compute separation. Our idea in this area, and it's like a big project for this year for Qdrant, is to push this idea to this logical limit and actually run inference and run queries not in just another machine in the cloud, but in your device which you control. How we can do this, right? There are two aspects of Qdrant which makes us, I would say, a best candidate to develop solution like this. Is first of all, we're open source, right? So the edge part on this diagram, this is something you need to run on your machine, on your mobile phone or your personal computer or on your own server in the cloud, but still it's controlled by you and owned by you. Therefore, you need to trust the binary you're running, right? And you can only trust it because it's open source. You can compile it yourself. You can validate that there are no spyware or anything like that. The second aspect is we are kind of own our own infrastructure, right? Our own development stack is something we develop inside Qdrant from the ground up, right? So we don't rely on any third-party storages, libraries. Earlier this year, we completely removed RocksDB from Qdrant source code. So we can, and we are doing this, we are changing the most fundamental components of the quadrant to be compatible with this approach of reading directly from different storages. And this allows us to build the most flexible approach to serverless, approach to storage and compute separation. Just think about it, that you can run a cloud-based service which does not charge you by requests. Instead, it will charge you by just egress from your object storage to your local machine, and everything else is done by you, right? If you need 1,000 requests, you don't need to pay 1,000 times for each individual request. You just download them, and the local cache does the heavy lifting for you. So I think it's very nice. I think many people will ask questions more after my talk. That's my goal for this evening. And of course, it's not only compute separation for search, it's also compute separation for indexing, right? In vector search, you might notice that indexing takes a real long time compared to all other operations you're making. It's something which makes dedicated deployments less optimal. You need to really care about how you size your machines, that if you're doing some bulk uploads, they may need more resources. When they just doing search, they may need less resources. And having this one big pipeline in one machine is sometimes hard to estimate. What we can do, because again we are doing a dedicated solution, we can offload indexing to a shared cluster of indexers, which will only do the indexing part, and we can basically build indexing the same way it happens in serverless, right? So you're not paying for dedicated resources where you don't need to, right? If something is spiky, if something happens only once, you don't need to book resources for the whole month to have it. You can still use the same benefits of a dedicated service with low latencies and no cold queries. At the same time, the heavy part of indexing will be offloaded and separated to the shared resources and built by actual usage. Yeah, do we have still more time? Oh, because I don't have any more slides.
About 20 more, don't worry.
All right.
Claude Design took care of it. What is the next slide? Is it thank you questions?
Yeah.
Then thank you questions. I am coming to you because we want to capture every millisecond and every beautiful voice in this crowd. Speak to it right like this.
I'm too loud. Thank you. Nice presentation. The question: does the indexing run completely local on my data, or is it connected to the cloud and then downloaded to the local device?
You're asking about Edge or about this one?
The Edge. The Edge.
This one?
This one, yes.
In this one, you can build it on your machine, you can build it in cloud. It doesn't really matter. As soon as you can download the snapshot, you can put it on the device and use it on the device, because usually devices are too small for big indexes, right? You, of course, can do it on devices if you want. It's just not that efficient.
Okay, thank you.
Anybody else? Anybody?
Back question.
Oh, hello.
I'll go for one. Yeah. Okay. Cool. Yes, you started your presentation by saying that grep is naive approach because it's regular expression. It's static. It doesn't understand similarity.
This one, yeah.
the grep.
It's a wrong question, right? So
Yeah, it's wrong. And because obviously, I mean, grep serves a different purpose, right? Like with coding agents, you want very specific search for specific terms.
I don't
right?
think it was my point.
Yeah, exactly. Yeah, I'm fully with it. I fully agree with you, right? And then, but we can also argue the same that vector search of today is also, so it's a more intelligent, but it's still, it's similarity, it's not relevance. And how...
What's the difference?
Well, similarity finds, try to maps similar word or similar context, but not necessarily relevant to answer certain questions.
I tend to disagree with this. It depends on how you train your model.
Okay, yeah, I would like to hear.
If you train your model to accurately represent what you call relevant, then it will be relevant. If you just use general purpose model, which happens to, sometimes match with what you call relevant, then it's maybe not that good.
Okay, thank you.
So I will take one more if there is one more, or I will take no more. Hey.
I'm actually also super stoked about Qdrant Edge, and you spoke about the use case, a demo that you showed. Could you enlighten us? Was it about robotics, or was it just you got a Raspberry that was in sync with Qdrant Cloud?
Yeah, so we don't have robots, unfortunately. So it was Arduino Uno, right? And it was connected to some very cheap webcam I could find in MediaMarkt. And what it was doing is it was capturing the images every second, put it into vector database. What is?
You're killing all of us. Like, we are a vector search engine
Right.
each at the beginning.
Right. So, and the idea is that you can do vector search on device, right? As small as Arduino gets, you can still do the same functions with the same API, very similar to the server. And like this is the first iteration, of course, where you need snapshots to synchronize with the server. But our big plan is to make it transparent. So basically what you would be able to do is to create an object, let's say in Python, and say, hey, connect to this bucket in S3. And it will connect, and it will not download the whole bucket to your machine. It will only query those bits of the storage which is actually needed to perform the query, and it will cache it. So this is the idea of storage and compute separation, which we have.
And the next goal is to do the demo on the glasses, the meta glasses. Mm-hmm.
I heard there is another demo about anomaly detection, which I didn't know about.
Oh, and we have also a couple of videos about the anomaly detection. So you can, well, it sounds kind of spooky from a Russian CTO, but you can run it on the security camera. You can also run the Qdrant Edge on the security camera to detect the anomalies. Also, the idea is to move it to the Roombas, all the little robots. I think we kind of, oh yeah, it works. The technology these days. You can also move it to a small Qualcomm robot. I think we ordered something to try it out.
Yeah, we never actually tried it.
And the goal is also maybe to try it on leaders or something like that. So, I mean, the sky is the limit, the classical one. I think it will be very fun to bring some robotic demos.
Yeah, the fun story is this year we went to this hardware Edge conference in Nuremberg, right? And those kind of demos was everywhere there, except they actually didn't use any cool technology. They stuck in the 2015 by the standards of AI development, right? So they're still doing those classifiers. They are still doing this classic OpenCV object detection on the cameras, which is kind of lame right now, right? So they are kind of lagging behind, and we are trying to kick them to move a bit faster. That's our idea.
Let's kick each other to move a bit faster. Right to the panel. So, firstly, while our panelists slowly will start approaching me and picking the chairs. And please be accurate because I try to sit on one and I mostly fall on camera, which I don't want to do. I wanted to say thank you to everybody because you did this event for me and for us. You drove the panel. All the Luma submitted questions kind of show how the audience reacts to what you're caring about. And I really hope that at the time of the guided networking, or kind of just networking that we will have after, you will have the ability to mix and match with all the people who have the same problems. That's why we had all of this very complicated coding scheme, which absolutely confused my colleagues. But the idea is that if you're running RAG in production, you can find your R people, your A people with agents in production, your people who are curious, and we also have Qdrant team members if you have any specific vector search questions. And we have T for tonight's panelists who came in time, and we also have Vasilia who should come here among other panelists who will get the letter T. So Vasilia, Bilge, Lelia, we are slowly getting here, and we will start our discussion on all of these topics, which kind of drew this panel fully inspirationally. My idea was to just take your questions, group them a little bit away, like the company-specific questions you can always ask from our company ambassadors, the questions that are specific about some productional stuff you can exchange at networking, but here we have our tool providers, our builders, which guide actually your agentic and your retrieval augmented generations productional pipelines. And we have representation of 5 companies which are in these pipelines. And we will do a little bit of introduction, but I promise you after that, pitching will stop and we will try to dig actually into the problems that you're facing. I will try to do it a little bit informational, so you learn a little bit, and a little bit fighty, but as much as we can afford ourselves. So for the panel, feel free to disagree, feel free to say, I think my opinion is different, feel free to jump in. We are doing it in the way that we want to do it. So, and now will be the round of introductions, but I will try to give you mics before. And for that, give me a short moment. So, we have these 2 mics, we have these 3 mics, and we will hand them around. They work with on, and they
Work now? Okay.
It works now. So now we're playing the game of gamble, who is coming first. And the first to introduction is a stunningly shining cognee. Actually, I feel like it might be also, if you're more comfortable, to a little bit stand up from the chair or a little bit like slightly move around. Probably our video crew is going to hate me. But on the other hand, I don't want you to feel uptight and worried that this panel is uncomfortable. I just want to talk to each other, maybe fight a little bit, and then also talk to everybody here so everybody leaves with a feeling that their questions were actually used. So, Vasilia, let's start with you. What is cognee? Why can we talk about cognee in the age of retrieval?
Sure, this is the most comfortable panel I've ever been on, so thank you.
Don't worry, we also have like only chair with 1 leg, if you...
I'll take you up on that one next time. So I'm Vas, I'm founder of Cognee. My background's in big data and cognitive sciences. I've built Cognee as a memory engine for AI apps and agents. I met Qdrant guys early on when I was just getting started, and I wanted to build a semantic layer on top of the vector stores. We also use Qdrant Edge, a great product for our memory on edge product, and we played around with that, but we've been building in this space for 3-4 years. We have investors from former founders of OpenAI, Facebook AI Research. We are often enough in SF, but we are based here mostly, and the team is located in Berlin. We have some researchers, some people that build things in production at places like Elastic. And why we are building memory is because agents can't really continue from the previous place where they left the things off. They always forget, start fresh. And we don't want them to make the same mistakes. We don't want to spend millions of tokens. And what we provide is the individual memory for each agent, for organization, for teams, and a combination of graph and vectors to find the right place in the memory that you need and completely improve it over time as you interact with it. We have this self-improvement based on human cognition, and that's a big part of our IP. So yeah, happy to be here. Super happy to talk to Qdrant guys. We love the product, and thanks for bringing us here.
Thank you very much. So now you know, when I saw a couple of questions on the agentic memory, this is the person. I'm not going to use the red light at the end, but you get it. The next one for the introduction would be, this is, you recognize the guy, you recognize the drop, you recognize the deal. And I hope the QR code is scannable. I know the arrangement is not, no, don't worry.
No worries, it's also just my
So
link.
Marcel, Dr. Eval, NA10.
Sure.
You guys know NA10, I bet, in Berlin. Raise the hands who knows NA10. You see, you don't have to do the introduction, we're skipping.
Yeah, because that's also why my slide is just visual. So you know NA10, and I'm one of the NA10 ambassadors, which by the way means I'm from the community, not official NA10, but I'm a heavy user of NA10. And I guess what makes my opinion at the end more interesting is that I'm really, really early adopter for AI agents. So I'm using and building AI agents since 2023, so pretty much from the get-go. I'm used LangChain a lot. Someday NA10 picked up LangChain, which was the moment that I figured, okay, I want to dig deeper in this tool. Just to mention a bit about NA10, I mean, you know it, but I guess nowadays agents have also evolved into some different niches. And yeah, NA10 itself is like a visual builder for automations and AI agents. In automations, you can connect your agents with virtually 1,000 services with NA10, and NA10 has a lot of features that makes it great for enterprise-grade agents. I guess I guess you can guess it, but my most liked features, the evaluation, which is also super interesting for running RAG and working with Qdrant. And I guess Qdrant grew also quite a bit with their, of course, RAG hype, and they were also a huge part of the NA10 community. It's a great combination, actually. So yeah, happy to be here.
Thank you. You know our hottest take of tonight? It's Qdrant, not Qdrant.
Yeah. I was also thinking about the most German way would be Qdrant.
Ooh, that sounds a little bit French.
Yeah, or in your LinkedIn post, I was also about Qdrant, which also kind of works.
So I hope I will manage to give a little bit more on the spin of the hot takes tonight, but I couldn't stay away from it. That was a very cheap pun. I'm sorry for that. The next one to introduction is coming LlamaIndex. Okay, let's actually. I didn't do it at the very beginning, and I'm sorry for that, Vasilia. But who knows LlamaIndex? There are fans, so please, Clelia, open sorceress, kick it off.
Hi, so we're LlamaIndex. I am a member of technical staff at LlamaIndex. I'm Clelia, and you might know us as a RAG framework. That's what we started as back in 2023, and right now we're a little bit different. We've been evolving, and we've been evolving towards documents and towards document intelligence, whatever concerns document intelligence, from parsing to data extraction to classification, segmentation of documents, whatever you can think of for documents, we have a service or a product for it on our platform, the LlamaParse platform. And what we also do and what we, pride ourselves in doing is we do not only offer these kind of tools as sort of like a stateless way of interacting with documents, but we actually build agents that talk to your documents, agents that retrieve knowledge from your documents, agents that understand your documents. So this is what LlamaIndex is today. We still, we are still rooted in, deeply rooted in AI, deeply rooted in our community that grew with us from when we were a framework to now, to a more like mature product. But still, that's our, I would say, identity. We parse PDFs. That's our like little motto, I would say. That's pretty much it. Happy to talk about whatever concerns agents and documents, and of course, Doc to be here tonight.
Interesting. So then it comes to that the LlamaIndex is less now about the orchestration, and we're coming to the orchestration great deal of Berlin, the deep set. So Bilge, kick it off.
Yeah, I'm waiting for you. Okay, so hello everyone. My name is Bilge. I'm working as a senior developer relations engineer at DeepSet. You see two names here, like DeepSet and Haystack. Haystack is the name of our product, and DeepSet is the name of the company. So sometimes I'm from Haystack, sometimes I'm from DeepSet. It's a bit confusing, I know. So like you can think of Haystack as the glue that brings all of these moving pieces together. You can like create like a defined flow with Haystack, or you can create an agent that brings like context, memory, observability tools, everything, basically that loop that we are building on top. And we have our open source, which is a Python framework, which is completely open source, free to use. You can start today. And we also have our enterprise platform. And it's a platform that you can use it on the cloud, or you can also self-host it, so if you have that type of requirement. And we love being model agnostic or any provider agnostic, so you choose which tools you want to use. So we give you the Lego pieces and you just build your app, and then you even ship it with the products that we have. As our customers and users, we are working with Airbus, Bosch, Siemens, Accenture. We are working with public sector organizations like European Commission and some federal ministries in Germany. So like they all use Haystack for their AI applications. And I'm happy to talk about a bit further, like during the panel and after the panel, if you have more questions.
Good. So now all the pitching ends, except pitching of Qdrant, obviously. Okay, so round of applause for our amazing panelists. And we will jump right into the questions. But before a little bit of the rules, I understand that the setup is not that easy to jump in. So if you will feel that you want to disagree, you can immediately do any visual sign. You can be like, or whatever. I run to you with a microphone and you can say whatever you like. I will try to voice over the questions because I get that it's a little bit hard that you'll have to tilt your head. And we will try to go through them one by one. I am kind of choosing how to approach them and who is answering them. But if you feel that it's your question, also give me a sign. Try to maybe stand up and run behind me trying to grab a microphone. And at the very end, by the way, so you don't feel left out, not only we left some questions for the networking, obviously, but at the very end, you will get a Q&A, and somebody who will be fast enough can ask any provocative question you want. But everything is recorded, so, you know. Let's start with the shift. I see that there is a line of how we are progressing in this retrieval agentic age. And now everybody faces this question, okay, do I need to make the next step? Do I need to move to these agentic pipelines? And the shift is kind of scary because everything before was deterministic to some extent. You do one step, you get your data, you know how to use it. Agents, well, they are dynamic. They decide to retrieve when, what, and how, and you suddenly lose control. So the question is, are we trading with this step reliability for capability? Maybe we shouldn't move anyhow to retrieval with agents. Maybe it's a bad idea for production. What do you think? I really want to start with DeepSet who orchestrates. So is there any guarantee of reliability, or maybe there are cases when people shouldn't even make this move? What do you think?
I mean, it's very use case based, obviously. So there are some places maybe you feel like, oh, you really want to have this agent that runs autonomously because you don't know exactly how to reach that goal. Okay. So like then it might make sense for you to switch to an agent, but honestly, like we are all talking about agents and they're capable, yes, but like maybe you want full control, or maybe it's such a highly regulated environment that maybe a more sophisticated defined flow, like a pipeline, is a better choice for you still. So you don't have to be all shiny and like market that you're using agents. And I think there's always like a sweet spot between like the defined flow and the agents. So if you can find that optimal spot, I think that's the right place to be. I know that's a bit like vague right now, but we might go into the details.
I heard the opinion that I was on this Berlin Buzzwords conference. I heard the opinion that you don't do agents for e-commerce, for example, too complicated, too much cloak of the context. I don't know if you need to stay away or not. Marcel, you adopted agents early enough. What made you think that like this shaky system can be even productionized? Maybe you, like, do you think it is actually productional, or is it only fun toys and games was all away, like all the time?
I tend to say it's also, of course, use case, and it's also the cheap opinion, as always, but I can also tell you that I had also great agents work, or in the end, they are not physical agents in the end, but naive RAG for a simple chatbot, and you have high control over the knowledge that you indexed into, for example, Qdrant, right? Then this pipeline is forced to use for every question the search. Like this is a deterministic part, right? Question comes in, it does the retrieval, it sees guaranteed 100 times, and the 100 times is the thing that makes the agentic part not so funny, but 100 times it sees at least what's semantically matching, right? When you control the knowledge, then you will have with that really, really good results, maybe even better results where compared to agentic. Comparing to agentic means, first of all, you have the trouble to convince the agent to use the retrieval. They are not always happy to use this if you implement this as retrieval as tool, not part of a fixed pipeline, right? So it's in the hands of the agent to use the knowledge base, for example. So it won't do this 100% of time. I can tell you, it's a hard thing. So, but what an agent can do, he can do multiple searches, right?
Yes, disagreement.
Yeah, I actually disagree with you. So we use a lot of hooks in Cloud Code and Codex and others to automatically inject the context into the agent's workflow. So you don't have to depend on it actually deciding on when to search. You can always give it a context. And we managed to flatten out the context retrieval at 50,000 tokens. So you don't end up in these millions of greps where like it's compounding and then compacting all the time.
Okay, now we are entering the grab stage, okay? No, but depends on the use case, right? That's why I started with the use case. And it's also why I started with if you have control over the knowledge. So the big problem with classic naive RAG is if the semantic finds too much stuff, then you can only put so much stuff into context window, and only so much stuff can the agent decide is it the right answer, and then you get also the noise part, right? So this is also the weakness of the classical RAG, right? Agentic RAG can make this better. I would agree with that as well.
I think we are on a similar page, although I think your talking point is a bit on like what is the problem with classical RAG, but with the current set of approaches which are often enough focused on either graphing to find the right context or typical tools on top of the stack with the graph representation on top, you are navigating the context better. So this problem is starting to get solved, and I think there is different ways also to manage the embeddings and as you mentioned on the training also that can impact it. So down the line, from what I'm seeing is that companies now, some of them that I met, have 700 agents, 100,000s of sandboxes running these agents and effectively managing the context by sharing either volumes or having a connection to some type of a memory system or that can be RAG. Often enough it is because it needs to be quite fast, but sometimes can be other things that allows them to effectively deploy and manage this at scale. And the basic pattern we've seen is that with the sandboxes, with the automation, often enough it's one human managing a group of agents, planner, execution agent, agent that is doing the tests, things like that. There's usually typical 2-3 patterns that we've seen, and with that, often enough, most of the problems are getting solved on this like low to mid level. When you need to think, yeah, there's still agents can't replace you on that on like deep analytical work, but for most of the things we've seen this automation kind of kicking in and going up the stack. So mostly B2C, less now B2B companies, even like people who don't know what GitHub is, have these automation workflows where they're automating a lot of things. So yeah, they're just a few observations.
Don't drop mic, but mic drop, but don't. Okay, so what about the last closing note of this slide, and then we move it a little bit to the next? You said that LlamaIndex is now doing more RAG, but at the same time it's like document agents. Did you make this shift? Did you stay at the RAG pine?
So we did make this shift.
Oh, for everybody, like this.
Sorry. We did make this shift. We did make this shift between traditional RAG and agents, but I would argue that it's not an out like it's not something that you have to choose. You have to choose out of RAG. You have to choose out of agents. Like they're not mutually exclusive. You can combine an agent with RAG, kind of what we were saying here before. Like you can kind of coerce an agent into getting the context, retrieving the context before then going on to graphing, reading, gathering more information, expanding. That's what we're doing. That's what we're trying to build. Also at LlamaIndex, we're like focusing on this product that we have, which is the version 2 of our knowledge base. And
no pitching.
Okay, and this version 2 that's connected, like version 2 is basically versed into agentic retrieval. So it's basically tools that your agent can use to first get the context, to retrieval from your knowledge base, whatever your knowledge base might be. And then once it has the context, you can then expand. But you just select a few candidates, you just select a few files, and then you read that file, you grab that file, and that basically solves kind of like the two problems that we have. You know, on one hand, RAG might be deterministic, might be fast, might be easier to scale in contrast to grep. But on the other side, grep gives, as someone was saying before, grep gives you the possibility of searching for a specific pattern within a file. So you get like both. You get like the scalability. You scale to millions of documents. You retrieve only the 10 most relevant one, and then you do read, grep, and search. So as I was saying, it's not mutually exclusive. You can combine both. You can work with both. You don't necessarily have to choose out of one in this shift.
So it feels like you are more pro this shift, and you're like, no, we're not treating anything for anything. We're selling tools that do agentic systems. That's why we are recommending you all to move to them. So, okay, then everybody pitched you that you need to move to the agentic systems. And then the question comes in, how to start without shooting yourself in the leg? Because you are picking up your tool, one of the 5 that we have here. And initially people, well, at the best case, they start with Claude Code, which gives you the nice advices. But in general, like decisions at the very beginning when building a whole agentic or retrieval systems are very rough. So could you give any examples of the technical decisions which are really hard to reverse. So if you do it bad, you do it bad for life. And this is the question for everybody. So we will start from left to right or from right to left? I see my CTO is trying to fall from the chair, so from right to left.
Right. So what's the question again? I remember. So which mistakes are hardest to roll back, right? Or like fix?
How to shoot yourself in the leg with Qdrant.
Well, that's very easy. Right, so if we are talking about stateful systems, the state is very, fragile stuff which you should care about, right? So LLMs in general are more stateless, right? You do this inference every time something asks a question, right? But how you store your documents, how you chunk them, is something you probably do not change every day, right? So it's important that if you do the chunking right, you have better accuracy and everything works nice. It's not like context should exist not only for LLMs, but even for embedding the context matters, right? That's why approach to how you store your data, how you partition it, that's something which, it's I would say the longest lasting thing in your system, which, harder to switch overnight than everything else.
So there were a lot of actually questions about how to deal with RAG in the sense that you chunked and you embedded everything and then information updated and you're like, okay, what to do now? Should I re-embed everything? So do you want it or not? But this guy is going to answer you later at the guided networking session how to migrate properly. Now, Vasily, how to shoot off your leg with cognee, how to run graphs, vectors, and everything, and absolutely make a bad decision.
What we've seen is often enough people don't really think about the schema of the data. So often enough you have a set of data silos in the organization. You might have relational databases, you might have PDFs, you might have Notion, Slack somewhere. And when you want to combine all of those and you want to have a one representation across the organization, you might need to think about how is that all connecting together. And if you have that column called revenue_2 that was only filled up until 24th of April 2023, and after that you used wizard socks and whatever people rename things these days do, you might want to have a semantic layer, a representation for that. Otherwise, you're going to end up in trouble where LLM's not going to really know what your business context is. And it's not going to understand what is your meaning of fiscal year, financial year, revenue. Is it EBITDA? Is it other things? What's a month? Is it in which calendar? How is it organized? So all of that type of stuff is something that often enough is for us a data modeling exercise where you need to spend a bit of time thinking. And then the solution might even be not to use our tool and to use something more simple because you don't need it. Or you might just need a RAG if you need something that can get there you fast and like you don't need that level of accuracy, or you just need an agentic loop if it's a couple of files in your system and you don't need to create a semantic layer. So all of that impacts the decisioning, the planning, and the pattern of implementation. But my biggest takeaway in the last year and a half is that whatever you do, you're probably going to make a mistake because things are moving so fast. So it doesn't really make sense to stop and think too much, kind of just move fast, make mistakes, and then iterate because the production of code is becoming commoditized. So it's no longer expensive to make mistakes as it was like 2-3 years ago. You're not going to be stuck with a system for too long. So I would say go fast and just think about the data model you're trying to solve for.
So everybody agrees that making mistakes and not thinking is a good choice.
Like, I agree that code is cheap and you can rewrite stuff, but imagine you have a production database. You can, make the second version of this database, but you still need to migrate and you still want to do it like zero downtime. This part is hard.
agree and disagree with you to a degree. I've been in migration projects that took a year and a half, right? And then you end up like, after that migration, you need another migration. Often enough, things moved again. My kind of takeaway here is that depending on the complexity of your problem, you might not need to over-engineer it for production if it's not a production use case, or if it's like a limited use case on an individual level. But as it comes to bigger production systems, yeah, I would put more thinking there than just building code, because what we are also seeing is like a proliferation of like 7 apps in the same organization that are doing the same thing and things like that. So you want to avoid it, but down the line, again, I think it depends on who's the persona here. So I agree with you that like, yeah, in a serious production system, you're probably not the safest way, but what we've seen is creating sandboxes and validating and having good harnesses for evals kind of solves a lot of these things ahead of time. And if you can cross-validate and have a good evaluation set, you can avoid a lot of these issues.
Yes, speaking of migrations, we just had an interview with one of our users who migrated from another framework to Haystack in 3 days. We even have sorry for the pitch, but we even have a migration guide for that. And I think that would be like something that you do like very wrong. If you start with a wrong framework that doesn't give you enough tracing or observability features, that will basically like make you create this black box that you don't even know like what you are doing. Because in the end, yes, you build this whole system, but if there's no evaluation in place, as you also mentioned, then how do you know the next iteration doesn't make it better or worse? Like you have no idea. And like basically as an AI engineer working on the project, you would have no idea what's going on. So that would be my answer, like not coming up with a nice evaluation set and not thinking about evaluation on day 0 is one of the worst mistakes that you can do.
Okay, so everybody talks about evaluation. Let me skip to the question about evaluation. You're all saying, okay, evaluate your stuff. How? How to evaluate that stuff works and how to trust these evaluations? Dr. Eval. You're Dr. Eval for a reason.
Yes. So let me read the question. How do you measure and maintain retrieval quality? From knowing a single result is good to knowing the whole agent loop landed right.
Nobody knows how to do eval.
Yeah, this was what I was about to ask, is who has ever done evaluation of AI agents? Okay, that's good amount.
You're raising his hand for him. Is it consensual? Okay. Then we have the people who struggled from doing evaluation, and they suffered. So please.
The thing is, as you already heard, it's definitely something that you need for retrieval, and there's also funny stuff like ground truth. So you need to know what's correct, so you can run it through the agentic pipeline and see if it's actually comparing good. By the way, the comparing, usually there are different methods of doing this as well. Most of the time, LLM-as-a-judge is also interesting, but itself also creates the problem that an LLM is judging 2 outputs. So you're getting like a probabilistic result getting valued by a probabilistic system, but it's a good way of having first tested if your retrieval pipeline is working well. And I can tell you, this doesn't need to be super, super complex. I know there are super, super decent eval solutions out there. Some softwares provide you with such things like N8N and I guess Cognee as well. But if you're from a developer context, you can really think this is test-driven development, but for agents. Like figure cases, what your agent should answer when given this input and compare it. There are several ways, and even like a naive eval will give you a good indication if things is actually good working.
I actually will disagree, and I'm interested, maybe you will give something more.
You just want to start the fire.
Yes, I do.
Oh, you want to start the fire.
No, but the fair point, everybody says like, just start with the use case. The worst thing that you can do in search is to just give your LLM-as-a-judge the question to answer if it's relevant or not, because you need to define relevancy. And what is relevant is actually the biggest problem, how to define it, because everything is in the head of the people. So maybe there is one practical recommendation on how to approach LLM as a judge, maybe in your platform, or maybe when it's actually not working.
LLM as a judge is, of course, as first the task for any LLM that is judging. In the end, there's a system prompt, right? And we want to get a number out of this LLM. It needs to rate this, gives us a number, like how accurate do you think is the result of another agent compared to the ideal answer, the ground truth, right? And it will respond with the number. We can compare and aggregate this number, and that way we get a score. Fine. How you can get to the score is actually what makes, I guess, eval so scary, because you need to figure first what to eval for, what is good, what is bad, and in the end you need to put this in a system prompt. First thing that makes eval scary, I guess, the system prompt. Of course, N8N has a blueprint, but you can customize this for use cases as well. And then, of course, I guess, the test set, the answers that are good, you need to source these need to be validated, right? They need to be validated that they're actually in the source. This is also a common mistake, like you put in some knowledge in the knowledge base and then you ask the people of the domain knowledge, you also mentioned it's in the head, and they start answer from their head, and it's never in the knowledge base. The agent answers and it never scores good, and you think it's your pipeline. But in the end, the problem is it's not in the source. And people who has it in their heads figured, oh, the agent should answer this. So also a bit of a problem of creating good test sets. Yeah, but to summarize, I guess, LLM as a judge works as long as you provide a good prompt, means for what it should judge. And of course, you need your test set.
Maybe then a quick one, because that sounds like a one-step thing. Maybe, Bilge, what about the whole chain?
I mean, so basically, yes, LLM as a judge is a nice, I mean, a metric. There are statistical metrics that you can still use, but you can compute lots of stuff deterministically. LLM as a judge gives you an idea of how your system is performing, like when everything is so non-deterministic. But like when it comes to the ground truth, you don't always have to have the ground truth, because like the people working with evaluation have done evaluation. How many of you had the ground truth, like with the questions and answers? Like, did you have any ground truth dataset for evaluation? Probably not, because that's not like, even if you have it, like it's very hard to compare it, even if you have an LLM in place. But if you have like a human expert in the house, you can just ask them to create like the initial data set for you, at least like a queries to test the system for. And then once you have your system on staging, you can collect the user data and put it in your evaluation data set, and then do this continuous evaluation if you really want to do that, and see how your system evolves, and if you really need to evolve that. So like this, again, it boils down to, I think, like seeing what happens in the system. Like maybe the problem is in your embedding, maybe the problem is in your retrieval, maybe the problem is in your generation. You need to very well understand like what happens in that system so that you can evaluate which part is broken. So it's not always end-to-end. Even if you're working with agents, they are creating those subqueries. Are you evaluating those subqueries? Like, are you checking if they generated the right ones? So it's a complex problem, I know. That's why, like, even like our users, they complain that they don't do evaluation in the first place, but there's a reason why people don't want to start with that, because it's ugly. I know. Yeah.
I kind of tend to disagree on a point, which is agents are, like, we treat agents as a system that is constrained to be non-deterministic. In a way, we should probably think as about agents as any other part of software. So when we evaluate something, sure, LLM as a judge is a great measure of output, But what led to that output is what we also should be measuring. So when we do evaluation, we should have a set of expectations of what the agent should have produced to get to that output. So for example, number of tool calls for a specific tool that we want to know how the agent is using, number of tools that, or like which tools follow that tool call, how many times the agent had to, go and read a specific file because it context switched, it compacted, and it lost memory. So all these kind of things derive from observability, tracing, and all agents nowadays, like all big agents, coding agents like Cloud Code, Codex, provide you with like these things that are called traces. You can basically, trace the events that go for the coding agent and analyze them and make metrics out, take metrics out of them, number of tool calls, as I was saying, or whatever. So you have a way of a more deterministic and more static way of determining the goodness not only of the output but also of the process, because that's what we're also interested in. Otherwise, we're just evaluating the output without considering, what's before.
To add on that as well, I guess for most RAG cases as well, is the source. If it actually used the source, this is like 0 or 1. If it found the source for this document, and this can be something that works like non-probabilistic, right? Source, metadata of whatever document we have contained in the result means it found the correct document, which could also be a great way of making sure your agent is finding the right, retrieving the right stuff.
Yeah, I think I agree with all of you on these elements. What I would see is like, if you're using human in the loop and you have an expert, theoretically it works. Practically you end up on a call with an Austrian expert on hydropower plants for 2 hours that doesn't speak English. And then you're trying to figure out why these plans in the 70s were designed in a certain way. And it's really difficult to get him to label the documents properly. So these type of, human problems start appearing, and you cannot really get to the output level you need. If you use LLM-as-a-judge, you're effectively limited to the LLMs, how well the LLM was trained and what is the capacity of the model, and the variability starts becoming an issue, so you can't really rely on that fully. What we've seen is often enough, I think, and something you mentioned on the managing the expectations, so creating a synthetic data set for a use case that you control, where you can effectively manage the expectations by encoding them in the data set you're validating and making that data set effectively synthetic data set as complex as possible, and then cross-validating with the real data. So if you're
I have a hot take on synthetic generated data sets.
It's not synthetic generated, it's human generated data that is you're managing the expectations of. It's not LM generated data.
Okay.
By the users, you mean, like collecting basically the queries from the users and then generating this data set, you mean?
Yeah, and having a research lead, for example, in the loop, which who validates the assumptions and makes sure that that's collected well. But yeah, there is a few steps.
Yeah. Okay. Yeah.
Okay. As long as it's grounded on user data, this is, I guess, works for me. Kinda semi-synthetic. What I hadn't had with synthetic would be just asking LLM for domain knowledge topic, generate me 10 good question and answers, right? And then you feed this in as knowledge, and then you have and here's the dangerous part, have the same model running the LLM as a judge. It's inside of the context window, not context knowledge of the LLM. So of course it likes its own answers that it's generated at the beginning of the pipeline. So when you have synthetic generation, you use the same LLM for generating this synthetic data without grounding with actual user data, and then have the same LLM judge the output. It sees its own output, what's completely inside of the context knowledge.
There is a question. No. You know what saved save it for networking. And I think I'm not gonna keep you all watching all the time. No, you know what? Save it for Q&A, which is going to come very soon. Is it controversial? Is it going to make them fight? Okay, good. We're taking that one later. Yes, I think like the main goal is to actually make you a little bit like, you know, heat up with listening to them and saying like, what, no? And then coming to them to networking and quarreling about that and us videotaping it, putting it on Twitter and getting insanely famous. I am not planning to stay on the whole schedule of all questions because I don't think it's the point. The point is just to discuss. So I will choose a couple of left. I think for me, there is a big context question that talks about the context window and the context rot, and I think Vasilia would be owning this question a lot, so I will just let you. So this is the guy who you need to approach when you have any questions about the context and memory. And instead, I will try once again for a little bit of a provocative question before we end up is, okay, you are kind of still pitching your product. You're like, it works, it solves all the problems.
I thought that's why we are here.
No, I am here to have fun and you're just victims.
You should have told us before then.
No, that is the whole surprise. That is the whole surprise, and the surprise is, let's try to be honest, your products are always the stack for every person out there. If you're an enterprise, if you're a solo developer, if you're a product manager, can you tell when your product is actually doesn't make sense for building these retrieval and agentic pipelines, and where it does a lot, like honestly and very fastly?
I'm gonna jump in for this one. Okay, so for at DeepSet and especially for Haystack, we have this kind of mantra. I mean, it's not official, but I think it's kind of like what everybody thinks is that we prioritize quality over quantity. So if you want this like very nice, very new thing that came up just yesterday through this research that everybody now talking on Twitter, and it looks amazing, you're not going to find it on Haystack on day 0 if it's not something fantastic and it's tested, because our mantra is everything needs to work, needs to be high quality, needs to be production ready. Because we test everything. Like if you ever try to contribute to Haystack, you're gonna hate our open source team because they're gonna tell you, oh, let's increase the code coverage, like test coverage of this PR. Or this test is missing, add that test. Even tutorials, like literal Google Colabs that we put on our website, we test them every night so that they work. So that's why like it goes a bit slower, because we need to make sure that this is something first, like something useful and something that is production ready. Otherwise we don't adopt it in Haystack. Unless, of course, you can create your own Haystack integration and make it public so that other people in the community can use it. But yeah. If you wanna try, like if you wanna break stuff on day 0 and then complain that it's not working, it's not gonna, Haystack is not the right product for you. But if you really wanna work in real life systems and take them into production and want to have a stable application, then you can really trust on Haystack.
I would say, of course, I mean, I'm representing N8N, but I don't need to hard sell you the tool because I'm just a heavy user of this tool, right? And I can tell you why I value N8N for projects of my own and projects of my clients, and also teaching a lot N8N for whole teams. And it's flexibility. You can build this with N8N, whatever you want. Could be plain input-output automation. It could be putting your first LLM call into an automation. It could be building your first agent. It could be building an agent team. And yeah, You can, of course, build even with the whole ecosystem. We have Qdrant. I'm guessing we also have good cognee connection. If not, cognee can make this possible as well. LlamaIndex as well, you will find there. And you can just build. And this is the cool thing with n8n. And even in an age of just asking a coding agent to build something, you can do this as well. With the n8n MCP, you can build agentic, less buzzwordy. You can just ask Claude, build me an n8n workflow. It will do so. You see this visually, which is a great way of confirming things are actually working. And I can tell you from current market movements that n8n has, for a reason, a heart at enterprise clients. Because it makes AI controllable with a great yet flexibility.
So everything everywhere all at once? No.
Jack of all trades? No. I guess there's something evolving, like agentic automation, just having Claude brute forcing tokens the way to do something. If you want that, do that. Might work for small use cases for your personal stuff, maybe for smaller teams, but you cannot scale this for bigger companies for real process automation, I guess. I always wanted or now I want to coin the term sniper agents. Like if you want an agent to do the job well and predictable, then you can do this with n8n. With true coding assistant agentic workflows, this is more or less hoping that it's got the context right and generates the stuff correct and there's no error inside of this. This is not the n8n way.
Interesting. I also hear from software developer community that they don't like low code for enterprises. Do you have a take on that?
Yeah, with enterprise, you of course get enterprise needs, which is like auditable things, having the traces that is particularly hard to get, having code execution running on local computers of employees. I wouldn't give Claude Code access to every person that I know that wants to do automation. And
who is running OpenClaw? Who is running Hermes? Who is running, who gave access to like Claude, who gave access to almost everything?
To your bank account?
Remember these faces. They are brave new world. Okay, now I wanted to also ask, do we have a take from our own company? Are we for everything everywhere all at once?
Yeah. So Qdrant is overall not a tool which agents supposed to use directly, right? So if you find yourself in the situation that you expose Qdrant to your agent, you're probably doing something wrong. Qdrant is a tool which is supposed to be used by other tools, right? Something like, yeah, right. And then our job is to pitch to those tools that the Qdrant is the best choice, right? You probably. Is it? Yeah. So if you are like running Claude Code, you probably don't need Qdrant, right? So for code, there are like billion other ways how to retrieve a proper function faster, starting from language server and going down to whatever functions you want. At the same time, for example, if you want to retrieve issues from GitHub, then semantic search is much more important there. And maybe having a better interface to GitHub is something worth to be a tool which maybe uses Qdrant even, right? So something to think about, especially once you start using Claude Code, you will have much more issues and pull requests on GitHub from this point.
We actually recently did a tutorial on that. So if you're doing something with that, we have stuff for you.
Yeah, on my end, if you need to connect your agent to something, try Cognee, you have one line with Cloud Code Codex, Open, Clone, Hermes, and automatically we register the agent. We're going to use the vector store, manage the graph for you. So effectively, you can just get started and running and share contacts between different places. What I've done recently is I was changing copy on the website, and it figured out when I was doing a pull request on the SDK repo and told me like, well, you changed the language, you should rename this function so it's more friendly. So these types of things get caught in the context and can be fun. What you shouldn't use Cognee for is probably if you want to do 1 billion vectors at scale, I would go to the Qdrant guys. They know how to manage that. If you need to do agent loop or orchestration, I would go to the Haystack people. We are not an agent loop. And if you are a marketer or a person that wants to have a dedicated workload that's repeatable all the time, NA10 is probably the way, or LlamaIndex for ingestion and parsing. We can use all of these with the integrations we have, but we are not an agent loop. We are not a vector store, and we don't scale to billions of vectors at the time. We can use dedicated stores like Qdrant to do that, but that's not our mission. So effectively, yeah, a couple of things there. Our use case is agentic memory.
Yeah, and from the side of LlamaIndex, for what concerns the document processing stack, what you want to use it for is to get good quality out of your documents, good quality text, good quality images, good quality tables. You want to retain the whole context. You want to do like you want to have rich markdown. You want to have bounding boxes. You want to have all these things that can make your application for sure better, can make your agent understanding documents better, pinpoint a specific thing, don't mess up a whole paragraph because it was parsed bad or crammed together by whatever like non-agentic or non-OCR parser out there. What you don't want to use LlamaIndex for is when you don't care about the structure of your document, is when you think that the document you have is fine as it is as text. If you are interested in your document is just like full text, your document is, you have markdown, you have texts, you don't need LlamaIndex, you don't need parsing for that. You don't need document OCR or structured data extraction. You can do that like simply with like an LLM or simply with an agent. But when it comes to like quality, when you want the quality out of your documents, then you should probably choose LlamaParse. If you don't care because it's not your primary use case, then don't. It's just not made for, it's just not for you because you just don't want it. That's it.
Perfect. Then I think that you will be able to start talking yourself. Let's just do the final, very fast, one-word answer for this. Like you probably hear about the age of agentic retrieval. People are talking a lot on Twitter about something, I'm refusing to call it X, on LinkedIn and all of that stuff. If in a couple of words, what do you think is overhyped? And each time you see it popping up next to you, you make this face like, eh, and you're like, that's never gonna work. Please, 1, 2, 3 words in the blitz go, and then we're giving it to the audience.
Agent-run companies. If you ever worked in Germany, good luck telling to Finanzamt that your agent's going to respond to that question. So I think that's something that's still not there, but people are raising 30 million rounds on that. So maybe in a few years.
Talking maxing, I guess, if you know what it means.
Do you know what it means? You will have to explain to everybody. Andrey, a few words on token maxing.
Yeah, it's a like idea that you just threw money into the problem until agent solves it. That's basically the idea. And the more tokens you spend, the more efficient you are. Like this is.
I start suspecting that everybody starts getting angry when they see a lot of money flowing somewhere. So
I'm gonna extend on that idea and say like these large language models, like big models, they get those context windows. That's great, but I think we're gonna slowly go back to those small models. I think that thing already started because we cannot afford those big models anymore for very specific use cases that we have. So I'm a fan of open source, also small models. So I think like every time like one of these big companies release a model. That's nice, but are we gonna really use it in production? Don't think so.
Is Anthropic already IPO? Is it like happening right now with
No comment.
no comments?
I'd say just use a skill. Don't get me wrong, I like skills. They're not that bad. I like skills as slash commands, but the problem with me is that you download a file that you probably don't read and that you inject into your agent. There are many more and more efficient ways to manage your context and to give your agent that knowledge, you know, that domain knowledge that don't need an unvetted skill that you download from somewhere on the internet on GitHub. So be careful. Don't just use a skill.
For me, it's agent harness. I don't know. It's such an ugly term. Like if they're writing the agent, and from time to time it feels like this is what they want to achieve. Like putting your agents in harness. I control this super capable Mythos model. Now it, don't know, writes emails. It feels like a super hype topic because it's actually what we are doing like from the get-go when agent building. Of course, we build something to make loops around them. We build context around them, and we had this. And now there's a fancy term, it's harness. And one thing I want to give you, try to notice how often the Anthropic models use harness in their vocabulary, because I have the feeling that the Anthropic models started this and some people figured, oh, this is so smart. Yeah, it's a harness and let's adopt this term, but it's actually not much new.
So we are adopting either what ChatGPT tells us or what Andrei Karpathy tells us. One of the
I see it way more in Anthropic models. If ChatGPT or GPT models would be the go-to, I guess we would talk in goblins, right?
Exactly. In M dashes. Okay, one question and the fastest one, even if like I see the hand, I'm running to that person, the most yes, and then we're going to move to the networking.
Make them 5. Okay, I'll try. So I was interested in your takes on, like we're talking harnesses and evals again. So for me, I'm old enough to remember a time when we called the human in the loop a user. And I was wondering, when we're doing all these, when we're validating basically, like can we use the human in the loop for reinforcement learning to improve the whole brittleness of the LLM responses? Because to me as an engineer, I feel like adding a somewhat brittle eval to stabilize a brittle LLM response is kind of like only half the way there. Can we improve that? Maybe with reinforcement learning, has that been tried?
It works, and it's also the best way. If you got human feedback on your output of the agents, it's the best feedback because you use human intelligence, right? They know what they are seeing and what they want. And of course, you can make it part. I wouldn't say reinforced learning because we don't train models. We do just retrieval, right? But let's say to make this really practical, what if you would add in the metadata of your retrieval like a score? Like humans rated this document as especially helpful, right? And make this score have an impact on the retrieval pipeline. Then you have your feedback system with the human validation inside of this. This would be my get-go way of trying this. And it's, I guess, also super easy to build. Don't overthink human feedback.
My answer would be that I know some companies that they collect the user input and then user feedback, and then they use these to create new prompts for their systems, and then they also evaluate the versions of those prompts and like to understand like if that new prompt is performing better than the old prompt. Of course, like there's so much human in the like the company side is involved in this process, but at least like they keep track of this this everything like coming from the user side to improve their systems. Yeah, so this is a real life valid approach.
We've experimented with this, and we got 1.7 million views on Twitter or X, depending how you don't want to call it. It was called self-improving skills for agents. So if you define a skill, and then you pass it through LLM-as-a-judge, but you can still, as a human, provide the feedback. You can rewrite the skill as effectively it's completing the task if you evaluate if the task complete or not. It can get as complex, you can do a gradient descent and all the fun stuff there, like can get that skill to continuously change as you're interacting with the outside system. And that's what we've seen works relatively well for people, and we include it in the core SDK. It's still naive, more naive than I would want it to be, but we are working on kind of thinking through that. And I think that connects again to this big field of continuous learning. And what we are doing internally, we have research team, guys from Berkeley, Brown, postdocs in neuroscience, where we are kind of treating the whole representation as an imperfect world model. And we are trying to navigate this graph vector representation in that way. And I think that's where things are going to go, because then you can effectively formalize better and kind of understand what the optimal path for solving a certain problem is, and where to drop off and where to continue. And it's a super interesting area, and yeah, happy to discuss that after. But down the line, I think like this is kind of where I see the paths going.
Yeah, I do have an opinion on this. Yes, human feedback and human in the loop and or user is super important. But at the same time, as Vasilia was also pointing out earlier, it's expensive. So you have to have someone not only that is like in the loop. Yeah, sure, you can have your users, but also if you want this feedback to be valuable in the sense that it can drastically improve the output of your model and you can really judge the output of your model, you have to have someone that knows, like has the domain knowledge of the kind of like application you want. So it's kind of expensive, and for sure it's very sexy, but at the same time you have to think about like the resources that you would have to put into it. So for sure it's good, but you have to put some thought into how to orchestrate the whole thing in terms of human resources.
Yeah, and in general, I am, as a person who studied machine learning, I also like the idea, and I saw agents coming in search. So how to do search trajectories effectively based on reinforcement learning pipelines. But also, as the person who studied machine learning, I have the impression that it's so hard to make reinforcement learning work properly. Oh my God. But when you do, it's rewarding. So I also think it might be an option also for the search and retrieval in general. The only thing that I want to say that I think it could keep going, but I also understand that the chairs are uncomfortable here and uncomfortable there. The pizza is coming, and I also want you to talk between each other. So firstly, thank you very much to each and every of you struggling through sitting in these positions and actually giving a lot of opinions. Please nod if you want to continue conversations, or shake your head about the vector search, about the agentic memory, about the orchestration, about the OCR, about the evals and N8N orchestration. And I hope that you kind of froze out of tiredness. I see these people. Firstly, they eat and then you come to them. And in general, I want to give a round of applause